Okay, so in these a bit less than 20 minutes, I would like to give you a little bit of an insight on the problems and the needs we have with the circular plastics economy. I will first shortly explain how difficult it is to eliminate plastics from packaging. The requirements then, if we come to the conclusion that we need a circular plastics economy, there are some requirements, design requirements, and it's not only design for recycling, but it's also two other Ds I will focus on. I will then talk about a little bit about the recyclability of plastics and also some regulatory aspects which are given by especially the EU in this context. Some technical issues which could help us to find some solutions for the dilemma we still have, and some conclusions in the end. First, laser pointer, yes, okay. The problem we have when we hear many people talking about eliminating plastics, we can see that in principle it would be possible to eliminate plastics from packaging, but only on the cost of many other targets we are following at the same time. So for instance, we have some severe targets as well in reduction of food losses, reduction in the total packaging consumption, and reduction of greenhouse gas emissions. And if we totally eliminate plastics and, for instance, replace them by paper plastic laminates, you can see that this would lead to an increase in packaging weight of 40%. If we completely would eliminate plastics, we would have nearly a factor of 5 higher packaging weight. And this would endanger a lot of other targets, especially the reduction in total packaging consumption and also reduction in greenhouse gas emissions, because this would lead to much enhanced transport effort. So we have to find some other solutions, and the general trend today is to talk about circular plastics economy. First, to look at the facts, how they are today, or let's say 1.5 years ago. We use in Europe about 20 million of tons fossil sources to produce plastics for packaging, and we recycle about 27% of them. Unfortunately, those 27% are mainly recycled into other products, and only 7% of the total are going back into plastics. We have other things that worry ourselves, like for instance, landfilling plastics, and especially not specified, which means that there is plastics leakage into the environment. So what do we need to get out of this dilemma of the low recycling rates and all the other things? And for this purpose, we have some so-called designs. Design for recycling, for instance, which is focused mainly. Design for recycling means that we increase the amount of recycled plastics, but it does not mean that we automatically increase the amount of plastics that goes back into packaging. The problem with this is that the demand of plastics is highest in packaging, so we need a path into packaging, and this is the second D, design for circularity, which means that we need to design the packages in a way that we can use recycled material in packaging again. And the third D, design for functionality, means that we need to be as functional, as efficient as possible to reduce the overall amount of plastics in packaging. This means that design for circularity increases this fraction over here, and design for functionality and design for circularity together are only able to reduce the total input in plastics into packaging. So this is the general trend. You may have a look at it, but the details are not covered by this. And I then go to the next step of my presentation, the assessment of recyclability. We at the moment have the PPWR draft, which asks for higher recyclability and gives some grades for it. But these grades are only related to the global recyclability, not to the recyclability or the reusability in packaging. And the same holds for the other different guidelines like CFLEX or European PET Bottle Platform and many others. They all look at the recyclability, but there are no rules, no criteria for the use of recyclates in food packaging. And this is something that gives us some problems. There are other problems as well. If you look into the EU regulations for the use of plastics in food contact and the use of recycled plastics in food contact, you will discover that there are very strict limits for possible contamination that may be in recycled plastics. And if we look at the same time on the regulation on packaging and packaging waste, where targets for minimum recycled content are given, you can imagine that there is an inherent conflict in this. We need to increase recycled content according to the regulation or the draft regulation down here. And at the same time, we have to be extremely safe concerning the safety of the consumer given by those regulations above. So the problem is how to solve this inherent conflict. This is summarized over here. Packagings have to be safe for the health, and therefore we need to find a solution, because we never know which contamination may be in a single package that's been recycled. We need to find a solution for this. One solution could be to improve more and more the recycling processes. This is something I cannot talk about today simply because of the restricted time. And this is one element of the solution. The other element of the solution is to avoid the transfer of contaminations into packed food if we use recycled material in the packaging. So the clue to this is the use of functional barriers. Functional barriers, I will talk about this in a minute, mean that we hinder the contaminations, the contaminating substances to enter the packed food out of the package. So this is the interim conclusion. We need functional barriers and we have to avoid specific contaminants. The first is the next part of my presentation. So what does it mean if we have a barrier on top of a plastics? We can look at a contaminated plastics, and this over time is the amount of contaminations that may go out of the plastics into the packed product. If we put a barrier on top of it, we can reduce this. A barrier simply means a polymer, in this case, that is put on top of the plastics, and the contamination has to cross this barrier before it can enter the food. So this is the principal effect. We go from here down to there, but we still have to calculate with some contamination that enters the food. This will never be zero, to be sure, but it can be kept to a very low number. There are other ways to use barriers. On the last slide, I talked about polymeric barriers on top of recycled plastics. Here, I talk about inorganic barriers that, for instance, consist of silicon oxide, like an extremely thin glass layer. This is something we already have today, and they are much more efficient against this. This is not shown in this presentation here because otherwise this line would be down here, very close to the black line. It's a bit exaggerated. So this helps us to reduce the contamination transfer by a factor of 100 or even more. So this is the principle of functional barriers. And in one of my last slides, I will show you some examples how these can be concretely designed. For instance, what we already have since even decades is the simplest functional barrier. We have recycled PET, and if we fear for some contamination to move from the recycled PET to the packed product, we can put a virgin PET layer on top of it. This works, but only for PET. This is due to the fact that PET has an extremely low diffusion coefficient, especially for higher molecular substances, and therefore this has already been proven that it works. If we go to other polymers like polypropylene, for instance, the problem of polypropylene is that the diffusion coefficient is much higher, so in this case we need an extra layer of a high barrier polymer. The problem with this is that it's not a perfect barrier, and you have to check very carefully the effect of this. By the way, you also have to look whether this structure is still well recyclable. If you keep this below a certain limit, it is. The inorganic barrier layers, they are also used already today. For instance, if you have a PET bottle or a polypropylene cup, you can coat it on the inside with a thin silicon oxide layer, which helps to reduce the transfer of substances drastically. And in this case, the functional barrier is enough to allow the use of recycled material here. If you use a film instead, this is a little bit more problematic because with a film you cannot allow that the outer layer is just inorganic. So in this case, you have to encapsulate the inorganic layer between the recyclate and another virgin material that helps at the same time to protect this very thin layer and to keep it in a laminate. So the good thing of these three examples here is that at the same time they help us to be a barrier not only against contaminants but also against oxygen and water vapor, so they increase the overall functionality of the packaging. Just some examples to show you how this concept may work. So I'm already close to the end of my presentation. We need to put more recycled content in food packagings. This is the requirement coming from circular economy. We have a chance to find a solution against the problems we have by using barrier technologies to reduce the risk of food contamination and at the same time giving additional functionality to the packaging. So these are positive effects, but there are still many things to be done. For instance, adhesives and printing inks may create problems in recycling. So we need either to have them compatible with the materials or to have them easily removable in, let's say, in the washing process, for instance. We have to look for sorting plants that are able to discriminate between food and non-food packages, because food packages are less risky in terms of contamination than non-food packages. Imagine packages where chemicals or mineral oils have been packed in. This would be detrimental for a recycling process, and this is something we have to avoid. And to link all these things together, we need to have a look at the whole packaging circle and to gather data all around it. So this is something we have to achieve in the future. And I have one final side remark. If you talk about bio-based materials and think that they are a solution where we don't need these complicated circles, this is unfortunately wrong, because also bio-based materials cannot be gathered for free, and you have to recycle them in the same way as for conventional ones. That's my short presentation. Thank you very much for listening. And if you have some questions, just write them into the chat.